Hi there, folks. Today we're looking at equations of lines in the coordinate plane. So we've been looking at lines from that kind of geometric perspective and kind of looking at the relationships between parallel lines and perpendicular lines and those sort of things. But now we're going to go back and review some of the stuff from our algebra days where we're looking at this in a Cartesian coordinate plane. All right. So the first thing we want to look at here is slope. Remember, slope or rate of change is the change in y over the change in x. That's how I have it listed second here. This is my personal favorite for doing this thing. If you want to go back to this old formula, that is fine as well. It means the same thing where you subtract the y values over subtract the x values. Make sure you subtract them in the same order. So second y minus the first y over second x minus the first x. But change in y over change in x yields the same result. It just converts the subtraction to a mental process, okay? And then the last piece of this thing, this is kind of when we're looking at a graph, all right? So if we have a graph and we can count the slope, count from one point to the next, how far up do we go, how far over do we go, that's the rise over run. For example, if I look at this guy, I'll do this first one using the formula, and the second one I'll use the change in y over change in x just to give you a kind of variety here. If you're using that formula, we are going to do the second y value minus the first y value. And be careful with your signs there. And then second x value minus the first x value. And again, it's really important. If I did 4 minus the negative 5, it has to be over the negative 2 minus the 4. All right, if on the numerator there I did the negative 5 minus the 4, the denominator would have to be 4 minus the negative 2. So just make sure you subtract in the same order for each of these. And now here's subtracting the same as adding the opposite. So that gives me a 9. Down here, same thing. Subtraction the same as adding the opposite, so that's a negative 6. And now I want to simplify this. That's going to be a negative 3 over 2. All right? And we don't typically write the negative sign with the denominator like we started with. We typically write it with the numerator or we stick it out front. Either one of those is acceptable. If I look at something like this next guy, if I do change in y over change in x, I just go from left to right. I look at the first point, and then I look at the second point. So I say, okay, when I look at that first point, the y value was a 4. And then in the second point, the y value is now a negative 6. So the question becomes, how did y change? Well, it went from a 4 to a negative 6, so it went down. But how many did it go down? So think about it in terms of a number line. To get from a positive 4 down to a negative 6, you have to go down 10 units. So the change in y is a negative 10. And that's the same thing you'll get if you do the subtraction between those values. All right? Same thing with the x values. It was a negative 1, now it's a 0. It's gone up, and it's gone up 1 unit. So that's going to be a negative 10. Okay? So you can either do your formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1, or you just do change y over change in x. It's a higher level way of thinking about it. All right? It converts some of this to a mental process, so it's less work, but you have to think a little bit more. All right? And then when we look at a graph here, again, I've got a couple of these. I'm going to start with something like A. So with A, we want to do rise over run. So we just have to find points that this thing goes through, like this one, this guy. All right? And we just count. And when I count these, I always go left to right. So I start at a point that's further to left, and I always work my way to the right. To count from one point to the next, to count from this point to the next point, I have to count up 1 unit and over 2 units. So rise over run, it was up 1 unit and over 2 units. And see, by always counting left to right, I only have to worry about using a negative when I go down. All right? If I look at B, line B here is a horizontal line. And remember, horizontal lines are in kind of that special case. It's kind of going up and down 0 and then over however many we want. Well, 0 over anything, 0 over 5 is 0. And remember, horizontal lines, the slope is 0. And the other way to kind of conceptually think about slope is we think about it in terms of steepness, all right? The angle. And so kind of relating those two things, we've been talking about it from the perspective of angles. In algebra, you talk about how steep the line is. We're referring to the same type of measurement. So when we look at something like B, the angle measurement going from a horizontal is 0, all right? There is no measurement to the angle. So there is no slope. There's no steepness here, okay? If we look at something like C, once again, I look at some points that this goes through. This one looks like it goes here, here. And again, I'm just going to start off to the left and I'm going to work my way to the right, just like reading a line or a sentence or something like that. So I'm going to start at this first point and count to the next point. To get from the first point to the second point, I have to go down 2 and over 1. So the slope, down 2, so a negative 2, and then over 1, so it's a negative 2. And then D is a vertical line this time. And if you remember, vertical lines are kind of so steep that we can't really measure the steepness anymore. That's the slope that's undefined, all right? And again, you can think about it this way. It's like we can go up and down as many as you want, so maybe I'll count up 10, but it doesn't move over left and right at all, so it moves over 0. Well, you can't divide by 0. When you divide by 0, it's undefined. If you want to use the null set symbol, that is fine. Or we just say undefined, okay, for our slope, okay? So then graphing equations of lines, there are two formats. There are 3 formats that we're going to look at. 2 of them utilize the slope. And the third one, we either have to use points to graph it, or we have to use the slope by changing the format. So the first format we're going to look at, this is the one that most students remember the best, is slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept. So if we look at something like this guy, we start with the point. Well, the point is the y-intercept. The y-intercept is a negative 1. So in other words, this crosses the y-axis at negative 1. And then the slope right here is 2, which is like 2 over 1. So I count up 2 over 1, up 2 over 1, up 2 over 1. And I can keep doing that. I can count down 2, back 1, keep the pattern going in the other direction, and then draw my line. And see, in geometry, we know that I really only need 2 points to graph that line. So why did I graph so many? Well, because I was drawing this kind of freehand. If I'm using a straight edge or a ruler, then yeah, 2 points will be absolutely sufficient. But if I'm kind of drawing this freehand without a straight edge, then yeah, graphing a couple more points makes the line easier to draw. If I look at this one, it's got a y-intercept of 2 and a slope of negative 1/2, so that's down 1 over 2. Down 1 over 2, down 1 over 2. And again, hopefully you remember this stuff from algebra. All right, this was kind of the bread and butter of algebra, was graphing lines and dealing with linear equations. All right. If I look at this one is in standard form. And this is the one we used a lot with systems of equations when we were solved by elimination. We would put things in standard form. But standard form is kind of one of those formats where students tend to not want to graph things from this format because we like using the slope to graph, all right? And if you want to use the slope to graph this one, you can. I wouldn't recommend doing it this way, but here's what that'll look like. We have to put it in slope-intercept form first, so you have to solve for y. So for this one, you would subtract the 3x, and then you would divide by that negative 4. And this is my distributive property. Negative 3 divided by negative 4 is a positive 3/4. 12 divided by negative 4 is a negative 3. And see, now I could graph that. I could plot the y-intercept of negative 3, and then I could go up 3 over 4, up 3 over 4. The easier way to do this one is to find the x and the y-intercept. And to find the x and the y-intercept, to find the x-intercept, I plug a 0 in for y. So imagine if I plugged a 0 in for y, you see what I would end up with the equation 3x, but then minus 4 times 0, well, that just cancels out. So I would end up with 3x equals 12. And if you solve this, divide each side by 3, you get x equals 4. So what I did was I got a 4 for my x value when I plugged a 0 in for y. See, that's the ordered pair that it's describing. Likewise, to find the y-intercept, to plug a 0 in for x, if I were to plug a 0 in for x, it just gives me a negative 4y on this side, and then equals 12. And if I solve this one, which once again I can do in my head, divide by the negative 4, that gives me a negative 3. So that's the ordered pair, 0, negative 3. I plugged a 0 in for x, and I got a negative 3 out for y. And when you think about what we just did there, it's a lot easier to do that than to rewrite this thing in slope-intercept form. But the result is the same. Watch this. If I graph those two intercepts, 4, 0 is right here. 0, negative 3 is right here. Well, that's the first 2 points I would have gotten by doing a y-intercept of negative 3 and a slope of 3/4. Look, up 3 over 4. And even graphing those 2 points, I can even see the slope by counting. And I could keep that slope going if I needed some more points. Okay? You have to choose what works best for you. If you want to rewrite the equation in slope-intercept form, have at it. But when it's in standard form, the easiest thing to do is find the x and the y-intercept, okay? Point slope form is the one that we tend to forget, all right? We kind of just toss that one out the window the second we're done learning it. It's y minus y sub 1 equals m times x minus x sub 1, where m is the slope, and the x1, x sub 1, y sub 1, that's an ordered pair that's on the line. And one of the things you have to make a note of here, and this is important for any place that you are using formulas and equations, is those minus signs. We look at them as minus signs in the equation here. A minus sign is kind of like an opposite sign, all right? We kind of refer to that as a negative symbol, but it's not really a negative symbol, all right? It's an opposite symbol. It just so happens like when I do the opposite of a 5, the number is called a negative 5, okay? If you think of those more as opposite symbols, man, formulas make a lot more sense. So what this says is y, then the opposite of the y value equals the slope times x, and then the opposite of the x value, all right? And so notice here, there's minus signs built into the formula. That means we're going to do the opposite of the value. So for example, if I look at this guy, if I look at the x value right here, that's not the x value, that's the opposite of the x value. So the x value is a positive 3. And here, this is the opposite of the y value for the ordered pair. So that's going to be a positive 2. That's what minus signs in a formula kind of do. They're more like opposite signs than they are anything else when we're interpreting that. And then the slope this time is a negative 2. And then from here I plot this. So 3, 2 is right here. Slope up 2 over 1. Down 2 over 1. Almost missed that negative sign. Down 2 over 1, down 2 over 1. And again, if I have a straight edge, you only need 2 points. All right. The other option here, if you don't remember point slope form, is you could convert this to slope intercept form pretty easily. You distribute this guy and then add that 2 over, all right? And that'll put that in slope intercept form. If you prefer that, that's okay. You could do that. Let's see, it would look like this. Negative 2x plus 6. And then you would add that 2 over to the other side and get a negative 2x plus 8. And that will give us the same line, the same graph that we already have, okay? If I look at this guy, again, looking at the opposite value. So if I look at the x value and the y value, and x is with x, y is with y. So I see x plus 2, so this is going to be a negative 2. I see y minus 1, so this is going to be a positive 1. It's the opposite. And then the slope is a positive 1/2. So now I plot that point, negative 2, 1. The slope is up 1 over 2. And again, I only need 2 points. But if I'm doing this freehand without a straight edge, graphing a couple more is not a bad idea. And once again, you could put this in slope-intercept form by distributing 1/2 and adding the 1. Okay? Last thing we're going to look at here is vertical and horizontal lines. We already talked about the slopes of vertical and horizontal lines. Vertical line, the slope is undefined. Horizontal line, the slope is 0. All right? But we also have to remind ourselves of the format of a vertical line and a horizontal line. Vertical lines are always x equals a number. Horizontal lines are always y equals a number. And students always mix these up because, well, the vertical axis is the y-axis, all right? So we tend to think about y as vertical, but x equals a number is a vertical line. Because when you look at the y-axis, the actual equation of the y-axis is x equals 0, all right? Because remember, the y-intercept is where x equals 0. The y-axis is x equals 0, all right? Likewise, a horizontal line, is y equals a number. Well, x, the horizontal axis, is the equation y equals 0. Because once again, it's where y equals 0. It's the equation y equals 0. And the other way to kind of think of it is think about which values stay the same versus which values change. For example, if I look at something like this guy, just looking at this, determining if it's a vertical or horizontal line, I can easily just do the slope, and I'm going to do change in y over change in x. So here, change in y, it was a negative 5, now it's a positive 7. It just went up 12 units. Change in x, well, x didn't change, so the change is 0. 12 divided by 0, well, I can't do that, that's undefined. Undefined means this thing is a vertical line. Okay? If I look at something like this guy, again, change in y over change in x. Y was a 3, it's still a 3, so y didn't change, so the value of change is 0. X was a 2, now it's a 6, it went up 4 units. 0 divided by 4 is a 0. And when the slope is 0, this is a horizontal line. If I look at this guy, again, change in y. Y value went from -1 to -1. It didn't change, so that's a 0. X value went from +1 down to -1, so it went down 2 units. So that gives me a 0. So that means this one's a horizontal line. And then if I look at this guy, the y value, change in y over change in x, the y value went from 3 to -3. It went down 6 units. The x value didn't change, so that's a change of 0. So that's undefined, which makes this a vertical line. Okay? So that's the idea behind slope. But now graphing these things, if I look at this guy, y equals 2. Remember, y equals is a horizontal line, so I go to the y value of 2, which is right here, and I draw a horizontal line. And again, look at the ordered pairs on that line. I've got 0, 2, I've got 1, 2, I've got 2, 2, I've got 3, 2, 4, 2, 5, 2, 6, 2. Notice what all the ordered pairs on this line have in common. They have a y value of 2. Y equals 2 is the equation. Likewise, x equals -4. I go to -4 on the x-axis. X equals is a vertical line, so I draw a vertical line. And again, think about the ordered pairs that are on this line, right? It's -4, 0, -4, 1, -4, 2, -4, 4, -4, 1,000, all right? The thing that all the ordered pairs on this line have in common is that the x value is a -4, okay? So it's the equation x equals -4. If I look at something like this guy, again, think about what that means. Y equals -3. Yeah, it's a horizontal line, but it's because the y value doesn't change. It doesn't matter what the x value is. The y value is -3. That's what that means. So y equals -3 means -3 is the y value no matter what. Okay?